In this video, we're doing lesson 5.1, which is on parts of a parabola. So we're starting into what are called quadratics, and that's anything with x squared. And if you were to put that in your calculator on the graph, it makes a U shape, which we call a parabola. And so there's a few different parts of a parabola. We're going to start with the vertex. The vertex is the highest or the lowest, depending on the way it's facing, point on a parabola. So in this example right here, this would be the vertex. And that is the point 1, -4. If the parabola opens up, meaning like this, the arrows point up, then we say that the vertex is a minimum or a min because the vertex is at the bottom. It's the lowest point. If the parabola opens down like this, then we say the vertex is a max because the vertex would be at the top. The next part is called the axis of symmetry. And the axis of symmetry is a vertical line that divides a parabola into two symmetric parts. It passes through the vertex. So something that you will notice about all parabolas, they're symmetrical, meaning if you were to fold them in half, these lines would overlap. And the place that you divide them in half, that's what we call the axis of symmetry, which I will a lot of times just abbreviate AOS. Okay, so it's that line. Now, when we write this, it's a line. Lines have an equation. You don't just put a number. So because it passes through the x-axis, we say x equals 1. Oh, sorry, don't write that there. It's always in the form of x equals, in this case, it's 1. But no matter what your parabola will be, it's going to be the x value of your vertex. So x equals some number. And in this case, I said it was x equals 1. You have to put the x equals. If you don't put the x equals, it's incorrect. Let's look at X-Intercepts. So an X-intercept is where the parabola crosses the x-axis. A parabola may have 0, 1, or 2 X-intercepts, and later on we will look at examples of each of those. Sometimes X-intercepts are called different things, kind of like nicknames, but they all mean the same thing. We might call them roots, zeros, or even solutions. But X-intercepts is the one that when you hear that word, you automatically think X-intercept. If I say, what are the zeros? You might be a little confused, but I am going to interchange those further on. So here is an x-intercept and there is an x-intercept. Notice here's my x-axis. That's where it crossed the x-axis. So this is the point -1, 0 and the point 3, 0. And then we have a y-intercept is where the parabola crosses the y-axis. A parabola will always have a y-intercept. It will have one y-intercept, but sometimes, just depending on the graph, it may not look like it. Because if the y-intercept is at like positive 100, your graphs generally that we work with don't go up that high. So it may look like there's not one, but there actually will be because these lines go up forever and they're slanted. But in this case, here is my y-intercept. That is the point 0, -3. So let's look at a few examples and label the parts. Oops, too tall. Okay. So this first example, let's find the vertex. So put a point or a dot where you think the vertex is. It's right here. And that is the point. You always do your x first. -1, 1. So does this parabola open up or down? Well, the arrows point down, so we say it opens down. The opening is on the bottom. And that means that the vertex is at the top, so the vertex is a max. The axis of symmetry is this line that goes through the vertex, right here. And remember, we do this x equals, and it's going to be -1 because it hits on the x-axis at -1, and that's also the x value of the vertex. So the x-intercepts here and there. So that's where it crosses this line. And that is at -2, 0 and at 0, 0. This parabola also crosses the y-axis at 0, 0. So the y-intercept is 0, 0. When it crosses at the origin here, that's going to be an x and a y-intercept, that point. Let's look at this next example. The vertex is that point. That is the point 2, -1. This parabola also opens down, meaning it is a max or a maximum because the vertex is at the top. The axis of symmetry is this line right here. And we put x equals, and then it crosses through at 2, or you could look at your vertex. Look at the x value of the vertex. X-intercepts. This parabola actually does not cross the x-axis, so there are no x-intercepts. And the y-intercept looks like it crosses about right there. It's kind of hard to tell. But that is the point 0, -9. Be careful. Don't put -9, 0. Okay. When it's a y-intercept, the number that it's on is in the y spot. When it's an x-intercept, that number that it falls on is in the x spot. All right, let's look at this third example. Vertex. Go ahead and write down what you think the vertex is. It's -2, -4. This parabola opens up, meaning the vertex is a minimum or a min because it's at the bottom. The axis of symmetry is this line. It crosses through at -2. So we write x equals -2. The x-intercepts here, and looks like it's going to hit at the origin again. So -4, 0, and 0, 0. And this one crosses, here's my y-axis, and it crosses that y-axis at the origin again. So 0, 0. All right, now I want you to try this last example by yourself. So the vertex, you should have got -3, -2. It opens up, and it's a minimum. The axis of symmetry, x equals -3. Your x-intercepts are -4, 0, and -2, 0. And your y-intercept, you can't see that. It's somewhere above 7, probably like 30 or something. So I'm just going to put unable to determine. Don't put none because it actually does have a y-intercept, just not one that we can see. So if you put none there, change that to unknown or can't tell, something like that.